Okay, thank you. So, yeah, I'm gonna spend a little bit of time on a concept. But before I do, I'm gonna do the typical, body poll. How many people in this room are from like a publishing background? Okay. And I'm assuming all of you attended the second keynote, David Gorbet's keynote, where he talked about the envelope pattern and the operational data hub. All right. Okay, so I'll take that as a yes. So if you're in publishing, you have been doing this all along. You guys are trendsetters. And I'm not just saying that to pander to you, it's actually true. So here's what I'm going to talk about. I'm talking about this notion of a new enterprise architecture pattern, enterprise integration pattern called the operational data hub. You hear about data warehouses, lakes, microservices, all kinds of things. Well, this operational data hub, is what is needed for managing data in the 21st century. And it's helpful to understand it when we compare it to some of these other integration patterns that have become popular over the years. So the first one dates back over 25 years, the data warehouse, right? Bill Inman's the father of the data warehouse, and he talked about a way in which to integrate data to get a unified, harmonized view of it for decision support. And if you look at some of the words here, like non-volatile, right, time variant, and just supporting decisions, the non-volatile one sticks out. It doesn't really scale for today's needs. But this was the first integration pattern from an enterprise perspective. It was the first time we said as enterprise architects, let's put all the data together, and it was with data warehouses. The key point to remember about this is that this was exclusively to support the observe the business functions. It's just to say, let's take a look at how the business is doing, find something out, and then tell the folks who run the business to do something differently. Okay? The run the business folks, about, we'll say, 16, 17 years ago, at the turn of the millennia, said, well, you know what? We need to integrate the run the business operations. Okay? We need to integrate these applications that do things. So they invented things in this category, this family of things called enterprise application integration. So service-oriented architectures, they stood up ESBs, and there was a lot of data exchange between these applications. But the data exchange was very ephemeral, right? It was very much about, there are these black boxes behind these endpoints. Pass the data in that you need. The endpoint figures something out. You close your eyes, you hope it doesn't crash, right? And voila, integrations happened. Okay? This is how we've been integrating the run the business function, unless you've been in publishing, because you guys have been doing it a little bit more smartly, because you realize that delivering information is your business, or if you're a publisher. So you've actually been doing this operational data hub without even knowing it. So let's take a look at these integration patterns and how they worked in a typical enterprise. We've got the run the business on the left, the observe the business on the right, and in the middle, these processes, these enterprise data management processes, right? Everybody, we've accepted this as gospel with respect to how to integrate data across an enterprise. This is what we've been doing if you're in enterprise architecture. And this is what Gary and David talked about earlier, how much money we're spending here in the middle. Because if you take a closer look, and you drill into these, and you look at ETL, we know what was the statistic? 60% of the cost is around integrating data. And if you look at this again, and you say the stuff on the left has intrinsic business value, the stuff on the right has intrinsic business value, what's the thing you celebrate in the middle? Hey, I've created an ETL job. How do you measure the ROI on that? Where's the money made? You can certainly measure the intrinsic business value when you're looking at the statistics of how your business is running, and certainly in your run the business function. But in that big sort of chunky middle, there's not a lot of value there, just expense. So we're clicking through this, even things like master data management, right? It's an important function that we've grown to accept as the norm. That after you've done all of your run the business things, now after that, let's master our data. Seems kind of backwards. And so on and so forth. And data distribution, so that's a little bit more on the right where you do actually get some intrinsic value out of it. But the more you double click into these, or single click in this case, if you're using this clicker, you realize that this piece in the middle has too much sway. And this has created an unsustainable gap between analysis and operations. We've accepted as normal the notion that the observe the business function and the run the business function are completely separate, and that there's this big expensive piece in the middle that we have to manage. And that's where this enterprise integration pattern that David alluded to earlier, the operational data hub, has emerged. And we just finally gave it a name. We've worked across many industries, not just publishing. But as we discover other industries that are doing things that publishers have been doing because they had no choice, right? You've had no choice except to manage your operations more efficiently with respect to the information that you deliver to your customers. Other industries have realized the same thing. So we finally gave it a name and said, yes, this is a new pattern. It does not exist in the lexicon of things like data warehouses or even lakes or service-oriented architectures. It's a new thing. And it's got a lot of differences. Okay? It flips things around where instead of being people-intensive, it's data-intensive. Right? It puts data at the center instead of people at the center. Think about it. ETL puts people at the center of managing your data, writing code. These concepts about not having to figure out the perfect model before you get value out of it kind of makes sense. If you think of the relational way of doing things, come up with a perfect model, and only then, after you get all the data in there, can you get value out of it. And contrasted with, say, the integration patterns for the run the business functions like service-oriented architectures or other EAI type things, it's data-centric. It's not function-centric. It recognizes the fact that when there's an interchange between operations, saving the data around that interchange is important. It's not a throw it over the wall, see what happens, and hope you're good. It embraces the notion that data is moving between these operations at an enterprise level. So we've actually given it a definition. We've tried like Bill Inman and said, here's a definition of an operational data hub. It's an authoritative data repository for cross-functional operations within an enterprise. Okay, and I've got all these other words. I won't read it. We're actually trying to shorten it. But I'll mention one point about the cross-functional operations. There are operations that you will discover don't belong in a single line of business application, but instead belong at the enterprise level. And the only way you can make them happen is with something like an operational data hub. And then all these other things like harmonizing the data, but more importantly, bringing the operations and the discovery closer together. So this is the summary slide for the operational data hub. And of course, you've seen this before. Repetition is good. The best platform for building an operational data hub is MarkLogic. And with that, I think I did okay, about 8 minutes, yeah? I'm going to turn it over to the real speaker of the day, Dr. Christoph Ludwig. Thank you.
So, thanks. So. Thank you. Good afternoon. I want to present you some aspects of a project that's underway at Haufe. I'm a software architect with the CTO office at Haufe. And the special thing about this project is that more or less for the first time within Haufe, our content is no longer just data that we shuffle back and forth between our applications, but we actually want to treat our content as APIs. The outcome of this project will be a central platform for the exchange of content, not only within applications within the Haufe Group, but also with partners. And just to give you an idea of the size of the project, we have on the development team 2 Java developers that had no MarkLogic experience beforehand. We have 2 MarkLogic consultants on the team who also contribute significantly to the Java services. We have a specialist from AppCont operations on the team who brings his expertise in the area of deployment automation and how to run MarkLogic in production. And then, even though all the developers are supposed to take care of unit tests, integration tests, etc., we also have a dedicated QA engineer on the team. So we are about 6 people who actually develop things, and that's a mid-sized project for Haufe. The First release of this application will be later this summer when our first consumer has actually migrated to our interfaces. And everything was built under a new technology strategy that came about last year. But before I tell you about the driving forces behind our APIs and how to design them, and before I can give you a high-level overview of the APIs that we got in the end, on what made us actually strive for this fully automated deployments, let me just begin with a little bit of scene setting. Since so many of you are from the publishing industry, I guess I can be quick here, but still for those who are not from publishers. Haufe-Lexware is a software company and media publisher, a family-owned company in the very southwest of Germany. And our domains are mostly tax, legal, HR, some real estate, but these kind of things. Publishing still makes about, I don't know the exact numbers, but I'd say about 25% of our revenue. Haufe, at the holding level, is split into a number of business units, here the bluish boxes, and those have all different target groups, consultants, key account customers, but we also do end user business, so we have this SPC business unit that targets consumers and small businesses, and so forth. The point being is that these business units all operate rather independently. In addition to those business units, we have quite a number of subsidiaries that in some cases are publishers that we acquired along the way. In other cases are software companies that provide SaaS solutions, again, either for big companies or, as in the case of SmartSteuer, for end users. Now, the publishing part of the business has its root, again, in the domains of taxes and law. And of course, Robert Haufe Verlag published books in the past, but we became market leads mostly with these loose leaf editions, where the customers would periodically get updates of new court decisions, changes in the law, and stuff like that. And by the 1990s, these had turned into digital databases, and customers would get silver discs every 2 months or so. Nowadays, these databases have moved into the web. So we have these online content databases as products. Some products are, again, for individual licenses or for large companies in key account cases. We publish news that target specialists in these areas. So we have about 50 editors who write these kind of news. But in addition to that, we also have booking platforms for trainings. One subsidiary of ours is one of the largest training providers in Germany. We have lots of SaaS solutions for accounting, you're doing your taxes, in the HR case, talent management, these kind of things. So it's now a lot of different applications, and due to the history of these applications, every application was built in a particular business unit or at a particular subsidiary. They all produced some content somewhere, or in some cases it was even their main purpose to have content. But, well, you guess it, we ended up with lots of data silos, and not only was the data distributed between these silos, it became very hard and expensive to maintain all these integrations and interfaces. So I think about 3 years ago, we took a page from your favorite software architecture book and came up with a hub and spoke architecture. So we said, let's put in a content hub in the middle. And that was also the time when we learned more or less by chance about MarkLogic and decided to base the content hub on MarkLogic. Bit fast, there you go. However, at the same time, Haufe underwent a transformation process. We got our first CTO. The CTO office was established. And we also got a new technology strategy. And the goal of this technology strategy is that Haufe should become what's called composable enterprise. Buzzwords aside, the goal here is that all our applications should become more interoperable, which helps us to evolve faster because we can replace applications. We need to be more customer-centric. Whatever the customer needs has to drive the applications. And back then, we didn't really have many partners accessing our applications. That's also something that should change. But that means we must support rapid onboarding, otherwise this simply doesn't scale. And scaling is one of the other driving forces here. We technicians think, of course, immediately at scale in performance, scale in load, but it's also about how can we run all these kind of things, how expensive is to keep on track and on top of the number of instances we have running out there, etc. These are all worthwhile goals, but the question is, how do you implement that? So one pillar of the implementation strategy at Haufe is the use of web APIs. In the context of the web, the term APIs has taken a little specialized meaning. Now it's about RESTful services that adhere to certain conventions. You expect a certain tooling around that. You expect certain documentation conventions. And if you do that, you want to achieve much easier integration because developers that do this integration are very familiar with what they get. The building blocks are very simple. And it will also give you a decoupling between the implementation and the clients, because as long as you adhere to the contract defined by the API, you can replace the implementation in the back end. Or, well, it doesn't always have to be a full replacement, but you can simply upgrade it. There are also things like Postle's law, be liberal what you accept, be strict what you hand out, and all these kind of things come together. The tooling you get for these APIs promises you to get much better insight into what customers are doing with your APIs, and therefore with your services. And also to give you back some control of what customers can do. Can have rate limiting and all these kind of things in there. This facilitates then that it's much easier to onboard partners, so you can extend your partner program and your general reach. Since you have more insight into the products, you will actually observe how people use the products, and most of the time it won't be the way you anticipated. So you will will learn about what's actually important to your customers. And then you can adapt to that. And maybe you can even unbundle your own products before the competition is doing that. And, well, if you unbundle your products, then you will also get new business models out of that. So, given all this background in our strategy, we said, okay, we need a content hub. From the 10,000 meter view, what do we have? There's always a content producer. There's always a content consumer. Otherwise, it's pointless. Somewhere is an implementation. And then we will put a gateway in between that acts more or less as a proxy. However, this proxy will take care of stuff like, of cost-cutting concerns like authorization, rate limiting, usage analytics, and all these kind of things. We have one API for the producers, an ingest API, and one API for the consumers. They can search, they can retrieve documents. When we took a closer look, we realized, it's not that simple. We actually have two fundamentally different types of content producers, at least at Haufe. There are the bulk content producers that run batch jobs. And at the end of this batch job, we have content archives with hundreds of thousands or even millions of documents in there, some binary content, and the zip file is about 1 gigabyte or multiple gigabytes large for the large products. So we must be able to ingest these bulk archives. Since transmitting such large files over HTTP is a little bit tricky, it's likely we will also need a file storage API that allows us to hand over these large files to the service implementation. In addition to that, we have the incremental content producers that produce one document at a time. And whenever an editor clicks on publish, this content producer will push this particular document into the content hub. So there it's a single document ingest. Given that, let's just take a short peek into how the implementation will look like at the building block level. We will have two services, one for the ingest, one for the search retrieval. The ingest needs some form of bulk storage, file storage, where we can keep the archives around until the actual ingest has taken place. But at the core of the Content Hub, there's the MarkLogic database. And in addition, we added a user interface where power users can do administrative tasks. They can drop certain content, stuff like that. The admin UI isn't covered by the API interface because that's actually a web application with a web UI. Everything else is only accessible through an API gateway. Now we knew which APIs we needed. Question was, how are we going to design them? And there were a number of guiding principles. Foremost, the outside-in approach. The API, or all our APIs, must be driven by the convenience for the client. It must never matter what's easier to implement on the inside of the service. And even more important, the implementation must never leak out through the API. So in our case, you will never see a MarkLogic namespace or stuff like that. It's all hidden behind the API. Second, ease of use. It must be easy for the developers to start programming against this API. And that's achieved by adhering to conventions if people recognize patterns or formats they are familiar with. Whenever possible, provide reasonable defaults, so they don't have to provide input data if we can use a default value instead. And of course, documentation that's easy to access, lots of guides and things like that. So the ideal would be that a developer can start programming against the APIs within minutes after starting to work with the documentation. He might not understand the full width of the API, but he can become productive and learn about the API. The third point is that the APIs should also be self-descriptive. So if we get a response from the service, the client should actually be informed by the response what are reasonable next steps, what are the URLs you can use for that. We actually tell the client what he can do. That's achieved by embedding hypermedia controls into our responses. These are the high-level principles. Of course, these need to be broken down into much more fine-grained rules and guidelines. We actually published them online, so you can look them up if you're interested. They are on GitHub. And whenever a developer, or since they're public, even you, disagree with some of the guidelines, the developer just has to send us a pull request, then it can be discussed. And that way, we can get into an interaction with our developers, whether the guidelines here actually make sense or what would probably work better. Now, back to our concrete APIs. Let's start with the consumer side. We did some kind of customer interviews, which meant we talked to internal applications and to potential partners. And of course, we came up with a list of standard features you would always expect from a search application. So full text, wildcards, facets, and all these kind of things. Suggest feature, no surprise there. There's also one feature that it's not available in your run-of-the-mill search application. That was the result aggregation and group by feature. The tables at the bottom try to illustrate that. We do a standard search with a score sorting. However, due to the data models some of our applications have, oftentimes we don't want to get the individual hits. What we want to get is all documents that share certain property to appear grouped under the most relevant hit. Sounds easy. The problem starts when you also have to guarantee stable paginations. I don't tell you the details how it worked, but just so much the fact that the search result lists can be lazily evaluated within MarkLogic saved our days. If you're interested in the details about that, ask Joe Green. He actually had to implement it. So yeah, that really was lucky that we had this feature here. However, as that in all our APIs, we should adhere to common conventions, stuff people know already. And therefore, the search expression language was inspired by some well-known search APIs, Google, Springer Link, and all these examples that are out there. And what we came up with is a search expression language that actually lends itself to open search descriptions. So again, we can embed open search descriptions either in documentation or in responses where clients and developers can see how to actually call our services. Also, the responses are OpenSearch response formats that we extended with some additional fields that we needed. But even if you don't know about our extensions, I'd say 80% of the search result you can use just right off. And only if you have special needs, you would actually to look up what we did with our extensions there. Since the OpenSearch responses are atom collections, we are doing a lot of XML, so we opted for the atom OpenSearch collections. And in the single document ingest case, it's also atom. The full single document ingest is based on the atom publishing protocol. So every content producing application has its own set of atom feeds. And just conceptually, all documents from one source are kept in one feed. That doesn't mean that some application has to download this full feed in its full length. Most of the time, the content producing application isn't interested in what it put there, but conceptually, it's there. There's also a second feed that allows us to hand over configuration information. For example, the Content Hub needs to know for which fields it should offer facets. And since every content producing application can have its own document types, each content producing application needs to be able to submit its own configurations. So these are the contract collections. Most of it is just atom pub. Again, we needed some extensions. For example, the ability to look up a single document just by ID. We had to embed the necessary information. Or since each content producing application has its own workspace, and Atom Pub doesn't say how you create a workspace, we had to embed the information how to create your workspace into the Atom service document, for which we used the Uber format. Because it actually allowed us also to specify the HTTP methods in XML data. Finally, the single document ingest also supports the XML binary optimized packaging format, but we don't force our clients to use that or to understand that and be able to do that. If they can't, well, it's fine if they simply embed it as base64. But if they can, then we understand it, and then it's obviously more efficient to upload the data as multiport HTTP messages. Things are a bit different in the bulk ingest case, because here we don't submit the XML content via the actual API. We have to start ingest jobs of zip archives, and only once the zip archives are expanded, we see the actual documents. And on top of that, the producer is not necessarily the same application that publishes the data. So we have some applications that produce content, and some other publication puts it online, and only when it's online, then it must appear in our Content Hub, because otherwise we would share data that's not online. So the first step here is that a bulk producer would notify the Content Hub that there is a new ingest job, and it would get back job ID, okay, plus some location where it can hand over the archive. Using the file storage API, the producer pushes the archive into the temporary file storage. And now it's up to the publisher to actually approve the ingest. And only when the approval is there, then at some point in time, the ingest service will start the actual ingest. When, that will depend on the load of the system and these kind of things. So it's totally asynchronous process. But at some point, the ingest service will pull the data, the archive, from the temporary file storage and push the documents into the MarkLogic database. So with these API constraints and these API guidelines, we addressed a number of these concerns of the composable enterprise. I won't claim that they are solved, but they're at least addressed. Still, efficiency is something that's not really solved by the APIs themselves, because you can have many APIs, you can run them in an efficient way, in an inefficient way. Yeah, it doesn't really help there. But our technology strategy here says that what we have to go for are fully automated deployments. So whenever we need to set up a new version or an additional instance of an application, it should be fully automated. We don't want manual steps in there. And we also aim for cloud deployments. It's not because we expect the cloud to be much cheaper, or at least in the case of the Content Hub, we don't really require the elasticity here, because we have a good guess about the amount of data we get in there, and at least in the beginning, about the number of requests we get from the clients. But within the cloud, it's much easier to automate these deployments. It's something we really can't get, or don't get at least, from our hosting providers that have our existing applications. Well, why do we want to do that? First of all, it's about speed. One of the new applications that we developed in the last half year was an API management solution. It's actually not the one we are using for the Content Hub, but doesn't matter here. And for that, one deployment is about 16 seconds. So obviously, there can't be any manual steps in there. I don't expect a Content Hub deployment to be within 16 seconds, but if it's online after, let's say, half an hour, still very good. For our existing applications, we typically have to announce them 2 weeks in advance, and the deployment itself then lasts for 3 hours or something like that. So we want to get much faster. Second is, experience shows whenever you have manual steps, errors creep in. Either people simply aren't careful enough, or you have a new colleague doing it for the first time. They don't know about certain steps. So in order to reduce errors, we have to make it repeatable. It needs to be written down how the deployment has to be done. And once it's written down in code, then it's written down. A deployment needs to include the testing. We need to start very early in the process with planning the deployments. And in the end, we want to automate it. Why? Well, we are producing content and we are providing SaaS solutions, but we are certainly not in the business of doing deployments. So for Haufe, there's simply no business value in learning how to do deployments. The more we can automate, the better for us. We can concentrate on what we actually know about, writing applications that deal with content and deal with the domains of tax, HR, and so forth. And the last point, well, the only thing that we know is that our hosting environments will change. We used to have a large on-prem installation. we have quite a large number of installations out there at hosting providers. By now we have some in the cloud, but which cloud provider will probably change over time. I'm not even sure that all applications will stay in the cloud once we figured all things out with the deployments and our hosting providers can provide this capability, then we might even move some applications back to on-prem or hosting providers. So this will change. And the only thing that we want to guarantee is wherever it runs, it's deployed in the same way. We use different technologies underneath, different cloud providers. And also the business scenarios change. Still, whatever comes there, we need to adapt to that. And only if we can quickly adapt, quickly bring out a new application, don't have to tell our business colleagues that, well, we can do a new release of this application in, let's see, 4 months. And that's, in some cases, the current situation. No, we want to be able, okay, let's make the change, press a button, and it's out at the customers. So, given that we want to move things into the cloud, if you look at the building blocks of the Content Hub we saw before, this becomes the following if we go into Azure. And yes, we decided to go to Azure. We have the Azure API Management Gateway in front, which is an different order, okay, which is a PaaS solution. We use the Azure Blob Storage for the temporary file storage. MarkLogic is run in VMs that use premium storage. And the VMs, the premium storage, as well as the Docker hosts that will run the services we have in front of MarkLogic. These are all infrastructure offerings from Azure. The services, as I already mentioned, run in Docker, and they are stateless applications, Spring Boot applications. So all we have to do is put one jar file into a Docker image, and we can run it. All state we would need, we can actually place into MarkLogic, so we can keep them totally stateless. And as I already mentioned it, the Azure Gateway and the Blob Storage are PaaS offerings that we get from Azure. The advantage here of the Azure Blob Storage is, for example, that it comes with its own file storage API, and it will also take care of the authorization. So we can hand out, together with the storage location, a token. It's actually embedded into the URL, so the client won't even see it. A token that gives this particular client the privilege to write a file to this particular location. No one else will be able to access this location or even read what's there. Okay, things are meant to be on the Azure cloud. So how do we get there? Over the last half year, a little bit more, our release engineering team at Haufe set up a GoCD installation. They also added a number of their own GoCD plugins and provided them back to the community. Another colleague of mine also specialized in all things Docker. So we have quite a good idea how to run things in a Docker environment. And by now, it's just 3 weeks back, we actually have the kind of official approval from the Chief Information Security Officer that we can run applications in a Docker environment. So what we then can do is the code is kept in Bitbucket repositories. Whenever there's a change, we can automatically build our services. Here it's shown as a Docker and a Go pipeline. Right now it's still in Jenkins, but it doesn't really matter because we can access Jenkins from Go, or we could migrate it at some point, whatever. And the artifacts, the jar files, are placed in the Maven repository. Whenever the artifacts in the Maven repository change, the next pipeline will run that creates new Docker images. And these Docker images are then placed in the Docker registry. At the top level, it starts with a pipeline that creates new base images for our virtual machines out there in Azure. The reason for that is we are running things out there, and our CISO requires that every application and every machine that runs in production must be fully patched. The last patch must not be older than 2 weeks. So if we run things at Azure, we need to be able to update our base images. However, we are not going to modify the running machines out there, but we follow the Phoenix approach, which means we create new base images, we set everything up again from the ground, and then switch over the machines. So we have a pipeline that recreates base images out there in Azure every 2 weeks or every week. These images are stored in Azure, and whenever we have new Docker images or a new base image, we have a pipeline that will set up a new test environment. There we can do our tests, and most importantly, we can also do our security scans against. And once everything is okay, there's finally a pipeline that will deploy things in the production environment and switch machines. Depending on which artifacts we build, it will either change the MarkLogic machines, or it will replace the Docker images, depending on what we did. Just to wrap it up, the fact that we concentrated on the APIs for the Content Hub means that we decoupled the Content Hub from the clients. So no matter which load the consumers will put on the machines, or no matter whether one of our content producers is currently down, we can still serve the consumers. We don't have to worry about cross-cutting concerns within our Content Hub implementation. There we can concentrate on the business logic. That's all now placed in the gateway. And due to the conventions we could follow, due to the Swagger documentation we have and all these kind of things, we expect that it will be much easier to onboard clients and for developers to use our system. And at least the feedback I get from the first consumer that's currently migrating, they see it as quite convenient. And for the automated cloud deployments, even though there is some work to do, we expect it to amortize very fast. We developed it together with a colleague from AppCont, and there we built on the expertise we got from them. Now we have reproducible environments. the dev team and the operations teams, once everything goes into production, won't be bothered anymore with all these tasks for the deployment. And we also can offload our security scans into the deployment pipeline. Thanks. Are there questions? Yeah?
What was the added value, the genuine added value of using MarkLogic as a persistent storage? Because the architecture you showed us,
Yeah, as one of the
any kind of persistent storage technology, what is the true
yeah.
added value of MarkLogic?
The question was why, what's the actual added value that we get out of MarkLogic here? And when we looked at what our options for building a content hub, we also looked at doing it with some other NoSQL databases and putting an extra search engine on top of that or next to it. And one of the main maintenance worries that we had and issues that we had in the past was we upload one of these large archives with lots of documents, and the uploading into the search engine works well, and the upload into the content database crashes halfway through. Now, how do you roll that back? Here with MarkLogic, we have everything in one component. So either the documents made it into the database, then they are searchable and they are available, or they didn't. But we can't end up with this kind of mixed up situations. Also, we have lots of content producers, and they have completely different data models. And there is no chance that we're going to harmonize these data models across applications. Part of that is for political reasons, but also there are different applications. There's a reason why they have different data models. And with MarkLogic, it's quite easy to keep on native, as we call it, the native format, native to the particular applications. We can upload that. Our content hub and MarkLogic doesn't have to worry about how the format looks, but it's searchable, it's indexable. And we can have a simplified format for consumers who are not interested in the specialities of the formats, but simply, I want a document that I can put on a web page, just give it to me, and I don't want to understand that it's actually a law or that it's a court decision or whatever. We can handle that here with MarkLogic. We didn't really see how to implement that with alternatives, or only with lots of effort and lots of coding on our part. Does it answer the question? Thanks. Yeah.
So my question relates to the answer you just gave. You have a native format, and then you have a simplified format as well. Is that provided by the original publisher, or is there a transformation you do in the hub to do that?
No, that's something we put onto the producer, because otherwise we as Content Hub would need to understand all formats out there in the company, and then we would end up again with, they do a release, and oh, they forgot again to tell us they added a field, or they add, and everything would break. So they know their format, they know how it should look like in the simplified format, what actually makes sense. The simplified format is XHTML, nothing else. So they can render it and hand it over to us.
Okay, so you would search the native format, but provide result from the simplified format, if that's what the consumer...
We let the clients choose. So the producers can add specified defaults, what should be searched for this document type. But if it comes down to it, the client can choose. Of course, we have defaults.
Thanks.
Any other questions? No? Oh.
Do you use anything special for Docker orchestration or Chamber?
No, actually not. There, it will be Swarm in the beginning. Once we have more Docker instances out there, then I guess the company will kind of standardize on some of the other solutions. We are tracking that. But right now, for the beginning, we try to keep it simple and stay with Swarm. Yeah?
Have you been tempted to use the MarkLogic native server application to build up your API so that you're not strongly coupled with Azure?
Well, we actually want to have this gateway layer in front, because first it takes care then of authorization or auth. We can have rate limiting at this level. It can automatically report and push information into central logs, these kind of things. That's where it's specialized for. And we are also able to put any kind of services behind that. We don't want to get too reliant at that level to what we can do in MarkLogic and then suddenly realize, okay, there's one particular feature. For that, we would have to add a service in front, but our API is at the database level. So that's not what we want. Yeah. Well, it took long, but that's not due to MarkLogic. I don't know how often we had to do significant changes in the MarkLogic database. There, it's more that staffing the project and then actually getting the requirements for the project to the table and getting a set of requirements that you can actually work off to the table. That was what took more time. So it's more or less 9 months since we started. If we had a finished set of requirements, a clear picture how it should be done, it would have been much faster. Yeah. Go ahead.
I will complete the question of my neighbor.
Yeah.
In that sense, do you have any advice to provide us on leading such a project? Maybe one project which is new, you've got for sure some failures. So any advice?
Well, this requirements topic is actually one of the main ones. We really need to understand about the data model that we need to handle. This aggregation feature is something that came up because we realized, okay, what actually is a document is something we don't have agreement on within the company. So in some cases, we have a huge document, then it's split into multiple documents. Is now a single paragraph of a law a document? Or is that something you can rather not present to a user outside? These kind of things are what actually took our time. These discussions where we couldn't really go forward and couldn't go really progress. Okay, then.
Do you provide any content staging?
For the bulk ingest, there the data is actually loaded into a staging database, validated, and only once it's validated, then the actual push in the production database starts. That's what we do there.
How do you validate it?
First, the archive has to have a manifest to tell us what should be in there, so that we don't miss suddenly some attachments or whatever. And then there are parts of the document where we have a schema for this, what we call the baseline format, the simplified format. We don't apply any schema, any validation to the native part because that's up to the provider. Similar for the metadata, there are very few metadata fields that are required. All other is optional. Okay, now, thank you.